Everyone is obsessed with real-time detection, but almost everyone is doing it wrong. They're stacking models like Jenga towers and wondering why their latency is 500 millimeters. You don't need a bigger GPU. You need a better architecture. Today we're dissecting RF-DETR. It's the first transformer-based detector to actually crack the real-time barrier, with over 60 map on COCO. No anchors, no NMS, just pure end-to-end execution. In the next 14 minutes, we aren't just looking at boxes on a screen, we're looking at the neural architecture search, NAS, and the Dynov 2 backbone that makes this a YOLO killer for complex environments. Why does this matter? Standard CNNs look at the world through a straw. They see local patterns. RF-DETR uses a transformer backbone, specifically derived from Dino v2. This uses global self-attention. The model isn't just seeing a wheel, it's seeing the wheel in relation to the asphalt and the horizon. This is why it doesn't get confused by occlusion, like a car passing behind a tree. Look at the code. This is a DETR derivative, detection transformer. It treats detection as a set prediction problem. You lose the anchor box headache and the non-maximum suppression bottleneck. It's cleaner math which leads to faster inference. The paper, argiv.2511-09544, highlights something most creators missed: neural architecture search, NAS. Roboflow didn't just guess the layer count. They used NAS to explore thousands of configurations to find the Goldilocks zone, maximum MAPI for minimum flops. This is why it's the first transformer detector to hit that 60+ MAPI mark in real time. It's not just about COCO, it's about the RF-100 benchmark. Real-world data is messy, it's dark, it's blurry, it's specialized. RF-DETR generalizes across domains better than almost anything I've tested this year. If you want to build a morphic media system or a traffic analyzer, detection is only 30% of the job. You need a tracking layer. Pairing RF-DETR with OC-SORT or ByteTrack turns these frame-by-frame detections into persistent IDs. This is how you get analytics: traffic flow, player movement, fruit count in an orchard. Without the tracker, you just have a flickering box. With it, you have a system. In medical datasets, we're seeing F1 scores of 0.78. That's massive for an open-source general-purpose model. It proves the architecture is robust enough for high-stakes environments. Now let's cut the hype. It's not perfect. If you're running this on a low-power edge device, like an old Raspberry Pi, the transformer overhead is still heavier than a tiny CNN. You're going to need an NVIDIA Jetson or a solid GPU to see that real-time claim in action. It also struggles with micro-objects unless you implement tiling. Don't expect it to find a needle in a haystack from 10,000 feet without some pre-processing. But for anyone building autonomous agentic workflows, this is your new baseline. Stop building toys. Start building systems. The code is open. The paper is peer-reviewed. The links are in the description. The real question isn't what the model can do. It's what you're brave enough to train it on. Build the machine. I'll see you in the next autopsy.